So in this series of videos about graphs of related functions, given a graph of a function y equals f of x, the following transformations are going to describe how to sketch the related function. So vertical shifts of our graphs take place when we have y equals the function of x plus or minus a, where a is the amount of vertical shift. So we're going to slide y equals f of x plus a units up or minus a units down parallel to the y-axis. So to consider vertical shifts, we're going to look at f of x equals x squared. So let's sketch that curve in. So we know that the curve f of x equals x squared goes through the origin, and it also goes through negative 1, 1 and 1, 1, and negative 2, 4 and 2, 4, and we'll continue up, but I'm just going to draw a section of it. If we want to look at f of x equals x squared plus 3, then what we're doing is we are going to add 3 on to all of the y coordinates and shift everything up, but our x coordinates aren't going to change. So if we look at our new curve, shifted 3 up, we've now got the point negative 1, 4, we've got the point 0, 3, and we've got the point 1, 4. So all of our points have shifted up by 3, but our x coordinates have stayed exactly the same. For f of x equals x squared minus 5, we're going to move all of our y coordinates down by 5 units. But our x coordinates again are staying identical. So you can see that our negative 1, 1 is now negative 1, negative 4, and our 0, 0 has become 0, negative 5, and our 1, 1 has become 1, negative 4. So in general, for f of x plus a, we're going to get a translation by the vector 0a, because 0 means there's no horizontal shift, and a means that there's a vertical shift of a units up, and if it was a negative a, it would be a units down. So what about horizontal shifts? Well, you can see now our transformation is inside the bracket with our x coordinate. So we've got y equals f of x plus or minus a. So we're going to slide y equals f of x plus a units left or minus a units right parallel to the x-axis this time. So again, let's consider the curve f of x equals x squared and sketch that in. So just like in the previous example, we've got our points negative 1, 1, 0, 0, and 1, 1 that we're going to look at how they're going to transform. If we've got f of x equals x plus 6 all squared, we're going to end up with a horizontal shift 6 units to the left. Now, it seems counterintuitive because it's x plus 6 in the bracket, but imagine that you equated that bracket x plus 6 to 0. If you rearrange it, you're going to get x equals negative 6, so it makes sense that our point is going to move to negative 6, 0. And you can see that our negative 1, 1 has moved to negative 7, 1. And you can see that our 1, 1 has moved to negative 5, 1. So our y coordinates have not changed, it's only our x coordinates that have changed. If we look at f of x equals x minus 4 all squared, again, we're moving to the right this time, because x minus 4 equals 0, if we rearrange it, would give us x equals 4 as our coordinate. But our y coordinates have not changed. So our negative 1, 1 has gone to 3, 1, and our 0, 0 has gone to 4, 0, and our 1, 1 has gone to 5, 1. So in general, for f of x plus a, we get a translation by the vector negative a, so it's going in the opposite direction, horizontally, and 0 because there's no vertical shift. What happens if we perform more than one transformation on the same function? So for example, if we perform a vertical and horizontal shift. So start with our f of x equals x squared function again, and we're going to look at those 3 key points, negative 1, 1, 0, 0, and 1, 1. Now, for the function f of x equals x minus 5 all squared take away 4, we can notice that that's in its completed square format. And so we can actually determine what the stationary point of that curve is. It would be a minimum stationary point at 5, negative 4. But how are we going to apply our shifts to prove that that's correct? So that x minus 5 all squared in a bracket gives us a horizontal shift of 5 units to the right. So we're going to move all of our x coordinates 5 units to the right, and our y coordinate are all going to stay in exactly the same place. So it means that our negative 1, 1 becomes 4, 1, our 0, 0 becomes 5, 0, and our 1, 1 becomes 6, 1. But our function is f of x equals x minus 5 all squared take away 4. So we've got a vertical shift 4 units down. And so you can see that we have indeed proven that our turning point is a minimum at 5, negative 4. And our other key points have gone from our original function at negative 1, 1 to 4, negative 3, and our 1, 1 has gone to 6, negative 3. So we'll look at one more function, and that's f of x equals x plus 3 all squared plus 2. So this time, our x plus 3 all squared tells us that we've got a horizontal shift going 3 units to the left. So that means all of our x coordinates are moving 3 units to the left, and our y coordinates are staying the same. Now we could predict that our turning point would be at negative 3, 2. So if we do that plus 2 shift, our function does indeed end up with a minimum turning point at negative 3, 2. And our other key points have gone from negative 1, 1 to negative 4, 3, and from 1, 1 to negative 2, 3. So in general, if we've got an f of x plus a plus b function, that gives a translation by the vector negative ab. So our vector is our turning point, so it's negative a, b.